Hello friends, today we'll see the problems on equilibrium of non-concurrent forces in space. Non-concurrent forces only, not in space. So earlier we have seen the problems on concurrent forces. For that, either we can use Lami's theorem or summation fx summation fy is equal to 0. Then what is the method of solving the problem of equilibrium of non-concurrent forces? And especially today we'll be considering a special example as beam, or you can write over here beams. Correct. Then first step is what? Equilibrium problem means very first step is pre-body diagram, BD. And in case of beam, always you use summation m about one of the support, it is equal to 0. The next step will be summation fx is equal to 0 and summation fy is equal to 0. And if you use these three conditions neatly, we can get the answer. So we'll see one of the example on this. Now this is the very first example which we are going to see. Determine the horizontal and vertical components of reaction at the supports for the beam shown in beaker. So this is at A there is a hinge support, at B there is a roller support. Hinge support is always replaced by two reaction components and roller support is replaced by a single reaction component which is going to be perpendicular to it. Then how to solve it? Now observe carefully this procedure. Probably beam is one of the most simple example in case of the mechanics paper. So how we'll solve it? So how to draw the pre-body diagram? See, whatever the beam is there, 6 meter is there. So you can draw this 6 meter beam as it is. And at B, replace the B, this support, by a single reaction component, and it is going to be RB. So it is going to be B. Then at A, there is a hinge support. There is a hinge support. Then at A, what will be there? There will be two components. Horizontal component we can treat as AX, and vertical component we can treat as AY. So this is A. This is A. And we have replaced the supports by the reactions. Similarly, whatever this couple is there, we have to keep as it is. It is 6 kilonewton meter. Couple will be as it is. At the same time, a point load is there. The point load will be also as it is. Only at this point load 5 kilonewton is acting and its inclination. Now at what I'll suggest, directly you can write the inclination, and that inclination will be what? Either tan inverse of 4 by 3 or sine inverse of 4 by 5. So it is going to be same. And tan inverse of 4 by 3. It is going to be 53.13. So this angle directly you can write 53.13. This is the angle. Means in the pre-body diagram you have to write the things like this. So this distance up to this, it is 2 meter. Again from this point to this point it is also 2 meter, and this distance is also 2 meter. So this is the pre-body diagram. And once we draw the pre-body diagram, then after that the problem is very simple. What I have told, summation m. So here what we'll do, summation m about A. Summation m about A, it is equal to 0. It is equal to 0. And here, see the moment of 5 kilonewton about A, it is going to be clockwise, and it will be 5 sine 53.13 into 2 meters into 2. So it is 2 meters minus RB into 4 meter. And this is the clockwise moment. Do not multiply by the distance. Only we have to write if it is clockwise plus 6, if it is anti-clockwise minus 6. Now here it is clockwise. Means from this we will get the reaction or component at B. It is vertical component only. Then what we'll get over here? RB is going to be 5 into sine 53.13 into 2 plus 6 divided by 4. 3.49 or 3.5. So this RB is 3.5 kilonewton and it is upward only. So only this, it is upward. You can show this direction. One answer we got. Now the same, only these 3 steps we have to follow in case of the beams example. Summation M, then summation Fx, then summation Fx, it is equal to 0. What will get? Summation Fx, Ax, horizontal component of the reaction, Ax plus 5 cos 53.13. There is no other horizontal component. So that's why moment will not be in summation Fx or summation Fy. It is equal to 0. Means we'll get Ax is equal to 5 cos 53. 5 into cos 53.13. It is going to be 3. But it is minus 3. Minus 3 means this direction is wrong. Please remember, it is not towards right, it should be towards left. Hence, I can write Ax is equal to 3 kilonewton, and it will be towards left. So this is the correct direction. So 2 components we got. Now, if we use third equation, summation Fy is equal to 0. For summation Fy, Ay, which we have to calculate, minus 5 sine 53.13 plus RB is 3.5. It is equal to 0, and from this we'll get this Ay. Ay will be 5 into sine 53.13. It is 4 minus 3.5. It is 0.5 and it is plus only 0.5 kilonewton, and as it is plus, this is going to be the answer, and it is upward. Finish. Means like this, easily we can get the answer. What is asked? Reaction component at the supports, and these are the components. At B 3.5, at A horizontal 3, and vertical is going to be 0.5 upward. So it is the complete solution of this very first example. Now we'll see the second example on beams. The beam AB with pin at A, means at A, pin means hinge support, and roller at B. Loaded as shown in figure, determine the reactions at the supports A and B. means we have to get the reactions at the supports. Again, what is the first step? First step is what? Free body diagram. How to draw the free body diagram? So whatever the beam is there, so we have to draw that beam as it is. Then whatever its distance is going to be there, so it will be like this. So it is the beam. And see, first you replace the supports. So whatever this support is there at B, it is the roller, means we get the reaction like this, perpendicular to it, RB. And at A, it is going to be AX and AY. So it is going to be AX, it is going to be AY. So it's A and it is B. It is B. Now, whatever the load is there, so where that load is acting? That load is acting at the center of this UDL. The center of the UDL will be what? 2.4 plus 0.8. It is going to be 3.2. And 3.2, its center means actually from this side, 3.2, its center. Center will be, if it is 0.8, again on this side it is at a distance of 0.8, means that remaining will be 1.6. So it will be somewhere over here. So this is going to be a point load. And then how much it remains? 0.8 plus 0.8 means remaining is going to be 1.6 plus 1.2. 1.6 plus 1.2 means on this side it is 1.6 plus 1.2, it is 2.8 meter. This is 2.8 meter. So this gap is going to be 0.8 meter and it is again 0.8 meter. So in all, total will be 1.6 plus 2.8, means it is going to be 4.4, and here also 1.2 plus 0.82, it is 4.4, means this free body diagram is correct as per the distances are concerned. Only thing is what? How much is this load? So that load is going to be the distance into 3.2 into 1800, it is 5760 Newton. This is acting downward. Means such simple free body diagram is there. Again, what we have to do? Summation M, summation Fx, summation Fy. Now here, summation M about A, it is equal to 0. Now see, the moment of AX and AY about A is 0. The moment of 5760 into 2.8 minus RB into this 2.8 plus 0.8, means it is 3.6. 3.6, it is equal to 0. Finish. And if it is equal to 0, so into 2.8 divided by 3.6, it is 4480. It is 4480. So RB is going to be 4480 Newton, and it is acting vertically upward. This is the reaction at B. Then summation Fx is equal to 0. Summation Fx is equal to 0. Summation Fx is equal to 0 means what? In horizontal direction now only Ax is equal to 0. And if horizontal component of reaction at A is 0, hence what we'll get? This AY means it will be reaction at A. Hence AY is going to be RA, reaction at A. Reaction at A. We have calculated reaction at B. Now we can use summation Fy. It is equal to 0. Summation Fy. AY means RA. RA is upward plus RB also 4480 minus 5760. It is equal to 0. And from this we'll get RA. RA is going to be 760. It is 1280. 1280 Newton. So this is the reaction at A. Reaction at A is 1280 and the reaction at B is 4480 vertically upward. Means the problems on beams are very simple. Free body diagram, summation M, summation Fx, summation Fy is equal to 0. So again we'll see the third example also. Third example. Beams example means always it is simple. Determine the support reactions at roller A and pin B. Means here it is directly mentioned, it is a roller support, it is the hinge support. Pin B for a beam loaded with 300 kg box as shown in figure. So what is the first step? Draw its free body diagram. So how we can draw the free body diagram? So whatever the length of the beam is there, you draw it as it is. So whatever this 3.6 and at a distance of 1.2 from this, it is the load. Weight we have to show like this, point load, whatever that. And if roller support is there, single reaction component and it is RA. This is A. And at B there is a pin or hinge support. It is two components, BX and this is BY. So how much will be? So from this point to this point, this distance is 2.4 meter and it is 1.2 meter. You can write like this. And the force will calculate 300 kg. 300 into 9.81. 2943. 2943 Newton. So this is what the force acting on this beam AB. So it is the free body diagram. And once we draw the free body diagram, then what I have told? Only these three equations. Summation M about A, it is equal to 0. It is equal to 0 and it will be 2943 into 2.4 into 2.4. The moment of Bx is also 0. This moment we have calculated minus By into 3.6. 3.6. It is anti-clockwise moment, hence it is negative. And from this I'll get one component of the reaction, 2943 into 2.4 divided by 3.6. It is 1962. 1962 Newton in upward direction. This is the vertical component at B. Now if we calculate summation fx, three equilibrium conditions, summation fx is equal to 0. What it is? There is nothing is there, only minus bx is equal to 0. Hence, bx is equal to 0. by we are knowing. If bx is 0, by is this. Hence, what will be the reaction at B? Reaction at B is under root bx square plus by square. So that bx is 0, hence Rb is going to be by itself, and it is going to be 1962 Newton. So this is the reaction at B. Reaction at B, it is vertically upward. And now if we use summation Fy is equal to 0, for all the problems common procedure, free body diagram, summation M, summation Fx, summation Fy. So Ra plus minus 2943 plus 1962, it is equal to 0. So what will get? .981. So Ra is going to be 981 Newton. Finish. See, easily we can get the reaction at A and reaction at B by such simple way. So again we can have one more example. Determine the support reactions of beam loaded and supported as shown in figure. Here also, first step is going to be free body diagram. And for the free body diagram, what we are supposed to do? Length of the beam will remain as it is. So it is going to be 6 meter. Supports at A, roller support, a single reaction, it is Ra. And when hinge support is there, always two reaction components we have to show like this, by and bx, by and bx, it is b. Now how you can convert this UDL and UVL into point load? So what I'll suggest you, so you can consider, so like this, from this to this, completely this is UDL, and then from this point to this, it is going to be UVL. So as per this lower part, UDL, what will be its conversion point load? It will be exactly at its center, at a distance of 3 meters. How much it will be? 600 into 6. So it is going to be 3600 Newton, and it will act at the center, means this distance is 3 meter as it is. Now for the triangular loading UVL, so it will be 1/3 from this, means 3 by 3, it is at a distance of 1 meter, and what will be its value? Half base into height. Half base is how much? Half base is 3 meters into height 900 minus 300 means so it is going to be 300. So I'll write like this, half into 3 into 300. Actually this value is going to be 450 Newton. 450 Newton. For your understanding, I have written like this. Means these are going to be 2 point loads acting like this. UDL or UVL you have to convert into point load. It is 1 meter, it is 2 meter, it is 3 meter, means overall length will be 6 meters. And if that length is 6 meters, then again what is the way of solving the example? Same procedure. For this beam, summation M about A equal to 0. About A, the moment of 450 into 1 plus 3600 into 3 minus by into 6, it is equal to 0. We'll get by. We'll get by. So it is 3600 into 3 plus 450 into 1 means 450 only. 450 divided by 6. 1875. By is going to be 1875 Newton. 3 unknowns, 3 conditions we are using. So it is going to be upward. Now, summation fx, when there is no inclined loading or horizontal loading, this value is going to be 0 only. Minus bx is equal to 0. There is no other force. Hence, bx is equal to 0. If bx is 0, one component is 0, other component is going to be the overall reaction at that place. Hence, Rb is equal to 1875 Newton, and it is upward. Then if we use summation Fy is equal to 0, it is what? Ra, which we have to calculate. Ra plus Rb, you can write 1875 minus 450 minus 3600. 3600, it is equal to 0. And from this, we will get the value of Ra. Ra is going to be 3600 plus 450 minus 1875. It is 2175. 2175 Newton. So this is the answer. Vertically upward. And now, if you see the solutions of all these examples on beam, what you have to do? These problems are very simple. Draw the free body diagram, replace the supports by the reaction components, and use these 3 conditions neatly. And you can get easily the answer. During the exam, don't miss the problem of beams. Thank you.